Hello, yes, it's Salah Nasri here, and yes, I have a special announcement. The game of chips has just hit 5,000 orders on Amazon. Thank you to everyone who placed the order. The book was just released in December, so I'm very, very grateful and surprised to date. If you are someone who is intrigued, curious about how the semiconductor ecosystem works from beginning to where we are right now, this book was written with you in mind. So order it, read it, and it is pretty much a handbook of the whole ecosystem. In the meantime, enjoy the next episode and don't forget to hit that subscribe button. Can you walk us through a moment in your career when you had to make a difficult technical or maybe organizational decision and what you learned from it?
Business goes through up and down cycles, and sometimes probably the most difficult parts when initiatives that everybody is enthusiastic, we have an effort ongoing, and then for one reason or another it fails. It could be because market conditions change, it could be because we couldn't execute well, or it could be competition was better. Project may fail, but real capital of any high-tech company are people, so to me, team is a key.
Our guest today is Dr. Oleh Krutko, Senior Vice President at imec.
He leads organizations where decisions are irreversible, timelines are real, and people matter more than outcomes.
Product development, which is driven by timeline, very strict schedule, cost, budget, all of those things that we know in industry. We are facilitating collaboration between the research, where research contributes innovation, knowledge base to our engineers, and engineering creates the foundation development flow. Almost 700 people in designs and system R&Ds. Managers don't succeed alone. Every individual within the team don't succeed alone.
What techniques do you use? What methodologies do you use to keep your team motivated?
I usually as transparent as I can be. I am pretty upfront with team what challenges we are facing. So I know that certainty is an idea that is not a reality. We need to embrace uncertainty.
Which mentors or colleagues would you say have had the biggest impact on your professional development?
Being humble and knowing that you're dealing with reality.
Hello, and welcome back to the Semiconductor Leadership Podcast. I'm your host, Salah Nasri. And yes, whether you are a semiconductor veteran or someone who's just curious about semiconductor manufacturing, this is your podcast. Before I start this podcast discussion, I have a very small favor to ask you all. Hit that subscribe button and also share it out there. The semiconductor industry is the industry that powers everything in this world. Now, we've hit remarkable numbers as of late. We surpassed the 200,000 views on this podcast. But as they say, it takes a village to raise a chip, and it takes subscribers to raise a podcast. So hit that button and share it along. Ladies and gentlemen, without further ado, it is with great pleasure that today's guest is Oleh Krutko, who is the SVP of Design and Systems R&D at the #1 semiconductor research institute in the world, and that is imec. Oleh, thank you for joining us on this session.
Thank you. It's a pleasure. Thank you for inviting me.
It's an absolute pleasure. And what's so special about this is we're filming it out of the Middle East. We're filming it live and direct in Muscat, Oman. And imec just recently announced that it's set up its first base here in the Gulf region, right next door in Qatar.
Absolutely.
Remarkable news. How does that make you feel? I mean, what does that mean to you?
It makes me feel very excited. This is very important collaboration for imec. We have great plans. We have a lot of opportunities for many people to join us in our semiconductor innovation journey. And imec Qatar will be a great place to work and move semiconductor roadmap further than ever before.
Marvelous. I mean, I think, the most important thing at the end of the day is kind of building that next generation of leaders, which is the mission that you guys are working on, and that is the purpose of that R&D setup in Qatar. What would you say is that the purpose behind that? Was it pretty much to gather the talent, the unique talent, as multiple great engineers in this region who unfortunately don't have that opportunity to be able to come out to Europe, for example, and have the opportunity to work at a great research institute in Qatar? What would you say was the kind of the drivers for imec for coming to this region?
So what drives us is that imec historically builds global ecosystem. We are already present in so many parts of the world, and we are not in the Middle East. And in the Middle East, what we see is a momentum. We see a lot of support from the engineering community, from government community, from academia, but they need people to come. They need companies such as imec to come and build that ecosystem here. So for us, it's a big value proposition. We come, we help to build ecosystem, we help with training people, we help with help shape curriculum at university, we collaborate with universities, we supervise PhDs, we give opportunity for young researchers, and then we essentially expand our global imec ecosystem that we are very proud of.
I love it. So, I mean, to begin with, Oleh, I mean, could you share a bit about your journey into electrical engineering and what initially sparked your interest in RF, as I believe, and based on your history and semiconductor systems in general?
Yes. So interestingly, I started my career in academia. I was teaching at theoretical physics department, but then I was really interested in making things happen and was interested in engineering. So I transitioned to industry, and I was absolutely delighted to see something that I made or I participated in making ending up in millions of people's hands and contributing to the quality of life.
I mean, how does that feel? Let's say, some people, they walk into in America, maybe they walk into a Best Buy, or in England, we have Argos, for example. Have you ever had that experience where you just walk down the shopping mall and we're like, hold on, my work is in that piece of technology?
Exactly. I can see that phone, the front end that I designed is there. I know that I was at Nokia for several years, and the base station that phones work to has the transceivers that I was working on. It's really a fantastic and very rewarding feeling.
I love it. Your career, of course, spans leading edge roles, as you mentioned, that Nokia,
yes,
great company, Qorvo, another great company, AMD as well, and now imec. Which would you say was the position, or let's say one would say the chapter in your career that basically shaped your leadership style today?
It's an interesting question, and I often ask this by more junior engineers, and even for my children who are both engineers.
Oh, wow.
Yes, I'm very proud of them. So what actually drove me from one place to another is interest. So I was, as I mentioned, I was interested in engineering, so I started working on technology development. Then my interest switched to design because I wanted to see the work that I was implementing in design engineering ending up in actual integrated circuits. So I moved. Then I wanted to learn systems. That's how I worked in Nokia. And then, of course, AMD is a fantastic company. I started at Xilinx, working with a brilliant team in Ireland. And, of course, Xilinx was acquired by AMD afterwards. And the projects that AMD does and complexity of these solutions are really amazing. It's a great learning experience. So every next step in my career was driven by interest to learn something new. What brought me to imec is an opportunity to learn how to manage business, because I came to be a general manager of industrial services, IC Link.
Okay. Can you share more about imec for those who don't know what imec is about out there?
I can talk about this for hours. When I first came to imec to explore the opportunity that I afterwards took, I didn't even realize that I only knew a small fraction of what imec does. imec is not only R&D. imec has multiple different business models and activities. Of course, it's an R&D. It's a core program. It's a technology development at the most advanced node, something that will come to manufacturing 5, 8, 10 years from now. But imec also does research in many other areas in semiconductor. It's health sciences, it's automotive, it's industrial. On top of that, imec also has industrial services. imec is a foundry of advanced silicon photonics. imec is a design service company. It's a design house that designs full ASIC from specification to volume production. And also imec is super active in tech venturing. So what really is exciting to me about imec is how many things can be done and what I can learn being in the same place.
Yeah. I mean, at imec, you're currently leading correct me if I'm wrong, the Global Design and Systems R&D organization. So that means you're managing diverse teams across circuits, systems IP, and ASIC operations.
Exactly.
How are you doing it?
Architecture all the way to volume production. It's an amazing actually opportunity because here we can start going through the whole cycle from developing foundational IP, from defining the architecture based on specification, then driving this to ASIC design, integration, all of the test packaging, and all the way to volume production. So even though the team is diverse, but we are united by one goal, by one purpose, by complex product that we do.
Amazing. I heard one of the challenges in some other companies, very large companies, who are kind of hitting a certain ceiling is because each department or division, even the department within a division, they behave like silos.
Yes.
That is not a feeling that I get from imec, dealing with the imec team.
Absolutely not. imec is very, very collaborative. So within design and systems R&D, we have very vibrant researcher communities, and then we have an engineering and development folks who develop something that gets to the field, to the hands of the customers. And we have a lot of collaboration and cooperation. In fact, our big mission is to take all of the research IP that imec developed over many years and still continues developing, mature it and take it to production, take it to our customers and to their customers.
So from that point, what would you say is the kind of, if you can share, is the secret to the alignment? Like how is everyone is aligned on one mission? Even though you've got so many different departments and divisions and projects and etc.
Well, I don't want to exaggerate, sometimes it's a challenge. And the challenge is not when we are doing a complex projects, because then we are all team working together on one activity. More of a challenge is that we want to make sure that we have a venue, an opportunity for innovation. And of course, that is not always compatible with product development, which is driven by timeline, very strict schedule, cost, budget, all of those things that we know in industry. So there are multiple ways to address this. What we are doing within imec, we are facilitating collaboration between the research. The research contributes innovation, knowledge base to our engineers, and engineering creates the foundation development flow that researchers can use to do things faster. So they don't start from scratch. They have ability to reuse building block to make their research faster. But it's still a challenge. It depends. In some circumstances, we would allow research to do some innovative and crazy things because this is what imec is known for, pushing the envelope.
Love it. From your perspective then, basically looking at your career, can you walk us through a moment in your career when you had to make a difficult technical or maybe organizational decision and what you learned from it?
Yes, of course, in business, business goes through up and down cycles. And sometimes probably the most difficult parts when initiatives that everybody is enthusiastic, we have an effort ongoing, and then for one reason or another it fails. It could be because market conditions change, it could be because we couldn't execute well, or it could be competition was better. So these situations are very difficult. So what I learned from this type of scenario in my career, and that the team is most important, making sure that we quickly regroup. We maintain the trust relationship between the team, because projects come and go, projects can succeed, project may fail, but real capital of any high-tech company are people. So maintaining the team motivation, team spirit, and trust, that takes us through this hard time. So that, to me, team is a key.
So how do you do that? What techniques do you use? What methodologies do you use to keep, your team motivated, getting up in the morning, saying, right, this is my North Star?
I usually as transparent as I can be within, of course, the legal requirements that most of us have. So I am pretty upfront with team what challenges we are facing, and we are jointly are very proactive what next opportunity we can jump to overcome current challenges.
So may I ask, how many people are underneath you, or how many people are reporting to you and indirect reports?
So the team is almost 700 people in designs and system R&D. So yeah, it's a very large organization with significant capabilities, and it's also geographically spread across 8 countries.
So what would you say? I mean, you mentioned transparency. You're very transparent with your team. What would you say is like the key leadership traits from your side that you have discovered in being essential in managing multidisciplinary engineering teams working at the forefront of innovation today?
Yeah, and this is interesting because regardless of the size of the team, it's very important that managers succeed through success of the team. Managers don't succeed alone. Every individual within the team don't succeed alone. We only win as an organization, as a team. So manager has very important tasks to not only create a vision or help forming the vision, building consensus, because as we start to do something complex, we need to all buy into that. We need to be all vested into that. And then manage a lot of tasks of management comes into supporting the team, making sure that all of the barriers and if there are any red tape, those are removed. So enabling team success.
I see. You've worked across RF, I'm reading here in terms of your background, millimeter wave, broadband, power products, and now system and circuit IP. What technological domain excites you the most today, and why, Oleh?
Well, that is true. I did, my interest took me through many different technical areas, and I was involved or had a privilege to be involved in many very interesting and exciting projects. What truly is interesting to me when multiple pieces of technology coming together to have fully functional working system. And this is why I really, really love working at imec, because imec has so many of these pieces, almost everything in many cases, that we can actually put as a puzzle together and make it work. So integrating different technology parts into one system, it's super exciting to me.
But I mean, at the end of the day, as systems are becoming much more complex, design and verification, of course, challenges grow on that perspective. What approaches or tools do you believe will define the next decade of systems R&D?
Yeah, and this is excellent question because it's a very hot area of discussion in industry. We know that co-design is already with us for many, many years. Designing ASICs with high-speed I/O has to be co-designed with technology, has to be co-designed with package, with a board in order to get the performance that we need. And indeed, with chiplet platform, with multi-chip modules, the co-design and verification becomes incredibly complex. So we are currently actively looking at various different research directions. We work very closely with EDA leaders. We work with Cadence, with Synopsys, with Siemens. We have great partnership with all of these three leaders in EDA world. But we are also starting to look what we can do internally. We do significant number of tape outs. In fact, imec IC-Link supports more than 80 tape outs in Europe from TSMC. So most of the work comes through us. So we have significant knowledge base, how we can use it. We also have very vibrant AI research. We have AI labs that we are currently setting up. So can we put this together and can we develop something differentiated that essentially can tap into our knowledge base and using AI technology? This is very, very interesting and active area for us. And this is what we want to do in Qatar.
Wow. What's interesting is that, when you look at the different sectors that you've worked on, so whether it's wireless infrastructure, aerospace, I presume even defense and measurement, how does designing for such varied applications shape your engineering strategy?
So the first and foremost, no matter what market we are designing, we need to understand application very, very well. Because in the end, if something, no matter how great it may be on the paper or in one measurements, if it doesn't work in the system, if it's not designed for the system, it will not be a success. What does it mean to understand the application and customer? It's more than just a performance. It's also, it has to be done on time. It has to be right price point or a cost point, and it has to meet reliability requirements that are also vastly different. For one reliability requirement is pertinent for wireless infrastructure, another is for automotive, yet completely different from space. But again, the key remains here is that in order to design a successful ASIC or FIC or MMIC is to understand the application. So that's the most important thing. Then, of course, from business perspective, it's ideal to be able to leverage the IP and building blocks and solution across many different opportunities and across many different markets. So the return on investment is much, much better.
So evidently, we've seen a huge global demand for advanced ASIC solutions. It's increasing like no tomorrow. How do you see imec's role evolving in the semiconductor ecosystem?
So imec is already in that ecosystem through our industrial services division, IC-Link. So we do quite a substantial number of ASICs. If I'm not mistaken, we are shipping very close to 100 million packaged ASIC every year and several tens of thousands of production wafers. So we are already in that ecosystem. So what we are doing at this point is that we are building and shoring up our capabilities across every development step of ASIC. From architecture, we have great architecture team, so to IP development, and this is digital functional design, analog mixed signal, and then finally go into integration, into physical implementation, tape out, test development, package development, NPI, and finally supporting production. So all of the pieces are in place, and we continue strengthening the team and increasing the size of the organization because, as you said, Salah, the demand is here, and we need great people. So again, imec is a fantastic place for all of you who are listening to join. Going beyond that, it's actually quite interesting. We discussed already the that AI drives compute demand. And of course, AI solutions, that AI revolution that is happening right now, we need to enable this. So our design tool, our verification need to be commensurable and need to suit the needs. Right now, the development could be quite complex, so we need to optimize design flow such that we can deliver something to the market in the time frame that customer needs. Beyond that, there will be other revolutions. Beyond that, we are looking at quantum computing. What really is interesting to me is how soon we can get to biological computing, because our brain is more efficient than anything we can do technologically right now. So there's no shortage of things. And this is where, again, the advantage of having both research arm and development arm come into play, because our research arm has many, many fantastic ideas that it's difficult to try in product development.
No, it's intriguing. But I mean, with all these type of like big objectives or big missions, Oleh, there's always going to be biggest challenges coming in and bottlenecks. So what would you say is the biggest challenges for ASIC volume production today, and how is imec addressing them?
Yeah, this is a great question, and to some degree a pain point for the industry. I think the supply chain constraints are pretty big challenge right now. So there is a lot of demand on the OSATs, on the foundries, and this is a difficult problem that all of us in ASIC business are trying to resolve. Our approach with imec is that we not only engage with our suppliers as supplier-customer relationship, but we also forming research partnership. We help our suppliers to develop next technologies, next material sets that they can use to advance their offering and their value proposition.
And if you're looking at, let's say, if we go on to the other side of, like, let's say, the RF and wireless industries, which have gone major transformations over the past decade, what do you think is going to be the next major disruption?
Yeah, that is interesting. If I think about RF, or if I think about millimeter wave, in my mind immediately is the image of connectivity. So, and that connectivity could be between the chips, it could be between the racks and the data center, or it could be mobile terminals, but in the end it's connectivity. Again, it could be wired, it could be wireless, it could be optical. So, and in many cases, the technologies and solutions are very similar and can be reused to some extent. If I look at more near-term opportunities for RF and millimeter wave, this will be integration, because many different ASICs now integrate high-speed data converters. They integrate very high data rate SerDes, and we are now looking at the next step of optical interconnects. Having high performance, high efficiency, manufacturable optical interconnect, I think is the next big thing for millimeter wave and RF.
So, I mean, going into that in specific, I mean, from my knowledge, imec is invested heavily in people that are specialized in silicon photonics.
Correct.
How many people have you guys hired? I can't remember. I think it's like a 3-digit figure, or something like that.
Well, our silicon photonics, again, expands through a large spectrum of different activities. So we have silicon photonic foundry offering that is a very vibrant business and growing business for us. So we also have photonics system folks, and we have photonic integrated circuit peak design team that is currently in design and systems R&D organization. So we do in fact have a significant community of both researchers and engineers in various different aspects of photonics.
And from a time frame period, when do you think this will become something in mass production?
The silicon photonics, to some extent, is already in production. We are shipping production volumes to industry leaders right now. In terms of on-board or co-package optics, and in particular, if we want to integrate optical interconnects between chiplets in system and package, there is still some work that needs to be done to make it viable.
You got anything in mind when that will be viable?
Well, I can only ballpark it roughly, but I would say 3-5 years, I think we should start seeing commercial solutions. And you probably have seen it yourself, Salah, is that most of the semiconductor industry leaders invested in acquiring these capabilities. And we can talk about AMD, we can talk about Texas Instruments, we can talk about NVIDIA. So this is where the industry is going. So optical interconnects will be there.
Coming in. Oleh, you co-authored 40 papers, and correct me if I'm wrong, you hold 7 patents.
Yes.
Is there a particular research achievement you're most proud of?
Interesting question. So I always think about my first job in semiconductor industry, where I started as a device engineer, and I was working on integrating bipolar transistor and field effect transistor, HBT and PHAMD. So, and this work was done, and it was demonstrated successfully and patented. And then this is actually quite interesting work, and I was relatively young in the beginning of my career. So I wanted to see where I can take this, because it's additional capabilities. Different devices allow you to play and create new architectures that in a single device technology one cannot do. So I moved to design team and actually designed the power amplifier based on this technology, and it was for mobile devices that protected the power amplifier against mismatch and also reduced the current draw, which is important for battery life. And this is where I saw something that I have done ending up in multiple phones that I assume sold in a huge number of quantities, which is, as I said, pretty rewarding. But what was interesting is that that technology essentially was also embraced by other design engineers. And in the end, the majority of the fab was using that technology flavor was completely dominating the fab at that point. So to me, I still reminisce about that, and it was really great work.
Nice. From your perspective, from your team's perspective, and just basically from your perspective, that will have a connection with your team, of course. What is going to be the biggest milestone from a short-term point of view and also a long-term point of view?
Well, from my team perspective, again, we need to realize our strategic objectives. So we are growing our ASIC operations significantly, and we are expecting this to actually materialize in a really short term, as we currently have very strong engagement with tier 1 customers. So that's the short term. We need to ensure that we have all of the capabilities to support these massive projects, and we are well on the way to do that. More longer term for us is, as I mentioned before, is the pipeline. imec IP is literally everywhere. One can look at any iPhone, one can look at any base station or data center. There are 100% chances you will find IP that was developed, originated at imec or done by imec researchers. So, but we have a lot more intellectual property, a lot more innovation that we can bring to bear to further grow our industrial services and, again, ultimately benefit our customers.
So what would be important to understand is with AI accelerating design flows or design workflows, it's a very important question I need to ask you now is, what impact do you see AI-driven tools having on the work that you're doing, or with RF, with mixed signal and systems design?
Yeah, and this is a complex question, Salah. So RF and mixed signal design or analog design in general has a different level of complexity. Sometimes it's compared to art. So I would think, and maybe I'm wrong, but I would think that RF mixed signal analog millimeter wave would probably happen a little later. First, you need to have viable demonstration that AI tools can demonstrate high performance building block, not only design, because they also need to be laid out in such a way that they're performing, they're reliable, they can yield in mass production. So that is definitely an interesting area that we will look. In terms of other aspects of design, I think the expectation is that AI tool which will significantly cut development time and also simplify the complexity of the design. Ideally, it would be essentially given the task in English, and at the end we would have the circuit design, integrated circuit design coming up in the end, tapping into the training, the knowledge base, and the tool that we can deploy. That's a dream. But in terms of simple metrics, I want to make sure that design is done correctly. We have first pass success in a shorter time.
What would be kind of like valuable for me to understand as well is you are dealing with, let's say, big pressure. When you're dealing with volume, with big volume comes big pressure. If I said to you, Oleh, I am going to give you 10% extra budget for this quarter, what would you do with it?
Well, personally, what I would do, I would invest it in long-term research. I am really interested in what's coming next after AI, what's coming next after quantum. I personally think that there's a lot of opportunities lay ahead. And one, as I mentioned before, is biological computing. There is something that we still don't know about how it works, how it's implemented. So to me, I would really plunge myself into trying to understand how it all works.
Yeah, I mean, it's interesting you mentioned this because I watched a great documentary. It was called The Thinking Mind or The Thinking Something, and it was about the story behind DeepMind, which got bought by Google. And one of the gentlemen's name, I can't remember his name, Debinas or something like that, who runs the company, and he was pretty much one of the key guys that kind of brought this AI initiative out there. So what he actually did that kind of brought him into AI is he was testing the program initiative, because it's pretty much just software, right?
Yeah.
And he was testing it on games. So the first test that he had was like a ping pong game where the ball was going up.
Yes, I remember that.
You remember that? Yeah. So he was predicting how the human will behave and when the ball will come through. And then from the gaming experience, it then moved on to playing against the best chess players in the world. And it was beating the best chess players in the world. And I think one of the elements that he was kind of passionate about, which he was struggling with, is protein folds. So when you mention biocomputing, do you believe that AGI will be able to help with this?
Well, I think absolutely. We will need all tools we can get because, again, we see the result of biological computing. We think, we talk, we make decisions, so it works. Yeah. How it works, we still don't know. And I think all of the tools that help us get there to understanding and potentially replicating something similar, we will need all the help we can get.
Oleh, what's your feeling about quantum computing? Is this something in your roadmap, on your team's roadmap, or is this something that's separate?
Yes, absolutely. imec is working on exploration for quantum computing. Again, it's a little bit further ahead in the future. There are various different tasks that need to be completed. But I think that's a really exciting area, and it could be a revolution that is coming after AI.
Oleh, on personal insight, perspective on your side, I'll be intrigued to learn or understand from your perspective what habits or routines help you stay effective within a very fast-moving field of representing leadership at the #1 semiconductor research institute in the world.
Yeah, so what I learned to do is that I'm embracing a change. So I know that certainty is an idea that is not a reality. The world around us is changing, so we need to be open to change. We need to embrace uncertainty. This is what I do, and every day we should be open to change our view based on the new evidence and based on new discovery that we see. So to me, I think that is very, very important.
The only constant is change, they say. What about mentors? Which mentors or colleagues would you say have had the biggest impact on your professional development?
Oh, yeah. So that is, I think this is an important question because, of course, within our career, we always had help and support from people. And then going forward, we are paying it forward when we help younger researchers and younger engineers to build their career, to build their expertise and knowledge, and finally become, known in the field. So I had privilege to work with many brilliant people during my career. I worked with people like Ali Khatibzadeh and Aditya Gupta, who were at the foundation of ALGAS and NGAP HBT technology that is currently in every phone, literally in every phone. So I worked with brilliant team and brilliant IMD and Xilinx Irish team with folks like Brandon Farley and Christoph Erdmann, who are as brilliant as people can only be. And I can also say that right now at imec, we have really gurus in mixed signal design, such as Jan Kranix and Pete Wambach in millimeter wave and RF. So I was extremely lucky during my career. But another interesting thing is not only technical, there is also business aspect of defining the strategy, defining the vision, knowing how to execute. So here I think, imec Executive Board is a truly fantastic organization that provides that guidance and that vision.
How do you envision imec's design and systems R&D roadmap evolving to meet future industry needs?
How do you envision design?
The roadmap from your division. If I said, Oleh, right, here's my crystal ball, we're going to fast forward 10 years from now. What do you see as the future?
So where do I see a roadmap as a much more complex system and packages with 2 nanometer and beyond technologies? This is already there, and it's only now realized by industry leader. They will become much more common. What I also see in the roadmap that ASIC will become even more widespread, not only in high performance compute or in data center or mobile phone. They are inherently much more economical, much more power efficient for many applications. And we already work with customers in biomedical field, in test and measurements, in fintech. They're everywhere. So I think ASIC proliferation is going to grow no matter what.
Oleh, we're going to switch the discussion now to a rapid fire question round.
Sure.
Hope you're ready for it. Just simply answer as fast as you can and as simple as you can. Let's go. Coffee or tea during long design sessions?
Coffee.
Analog, digital, or RF? What's closest to your heart?
RF.
RF. The first thing you check when you wake up, email or news?
Email.
ASIC or SoC? What's more fun to build?
SoC.
Favorite engineering tool you can't live without?
Oh my God, this is from my previous career, Keysight ADS. That was a tool I was living with for many years in my life.
Keysight ATS. What's harder, managing engineers or managing deadlines?
You really don't manage engineers, you support engineers. You manage deadlines.
A technology you think is overhyped right now?
Great question. I cannot even think of something that is overhyped. Of course, AI is here, but I do not believe that AI is truly overhyped. AI is already demonstrating potential. It's an interesting question. I know that's not a fire chat question, but investment in AI is massive and return is not fully realized. But what we saw already is super promising.
Okay.
So I believe it's real.
A technology you think is underhyped and deserves more attention?
Wireless communication. I think right now it's going through rough time, but it will still be required.
Preferred way to unwind after a long day?
Long run.
A long run. First job you ever had in engineering?
Device engineer at the company called Anadigix.
Anadigix?
Yes.
The toughest part about RF design in one word?
Interrelationship of the circuit and the layout, and everything else to make it work.
A book that influenced your thinking the most?
Great question, but I cannot think of immediate answer right now. I'm gonna take it
later?
Yeah, I'll take it later.
What's one thing every young engineer should learn early?
Don't be afraid to learn new things.
To learn new things.
Absolutely.
If you weren't in semiconductors, what field would you be in right now?
What?
What field? What industry would you be in right now? What job would you
I would move on into something new that I haven't done before. This is what I really like throughout my career. I want to learn new things.
Any field in specific?
Biomedical. I would explore that. I would explore genetics. I would explore something that is completely outside of my area of expertise and my comfort zone because it's so new, it's so interesting for me.
Respect. Favorite conference to attend?
RFIC.
RFIC. I was gonna say ours.
You're close second, so sec. But RFIC is my conference really.
Wait, where is RFI? I've never heard of it. It's the first time I've heard of it.
So it's Positive International Microwave Symposium. Okay. So it will be, I think it will be in San Diego this time. It goes to different places in US. And this is where all of the experts in RF and millimeter wave come together.
Interesting. Is it very engineering for engineers? It's engineering. Okay. Yes. Cool. Simulation or measurement? Which gives you more satisfaction, Oleh?
Measurements only.
One engineering myth you wish people would stop believing?
That simulation actually gives you correct information. Until you prove it in measurements, they are not real.
Fair. The most exciting emerging trend in semiconductors today?
I would still say AI. I think this is a very exciting trend right now. It's going, it's here, it's real. So this is it.
What's your go-to productivity hack?
Honestly, it's just interest in what I do. So when I'm interested, I don't keep track of time. I just do that because I like it.
One invention you wish you had created?
Invention of transistor.
The invention of the transistor since day one.
Absolutely.
Wow. That was a game changer.
Absolutely. There's everything.
Yeah. If you had to choose research, design, or management?
It depends on the stage of the career. Right now, I truly enjoy doing the management because I think I can contribute more. But I like working in research. I like working in development. So I think it's a stage in life and what you are really interested in at any given time.
Favorite country you visited for work?
I would say, well, of course, many countries that I visited are great for work. United States is a fantastic place. There are the cutting-edge technology. There are a lot of investment opportunity. So I would still say United States is my favorite country.
The most important leadership quality in one word?
Openness to other opinions and other points of view. It's not one word.
It's more word. Well, openness is, I'll take that openness. One semiconductor company you admire, of course, outside imec?
I truly do admire AMD. I was really privileged to work there. This is a fantastic, very focused company, pushing envelope in technology, have really great people. I do admire how they work.
Didn't expect that. Impressive. Okay. Hold on. 3 words that describe your approach to engineering.
Being humble and knowing that you're dealing with reality. You cannot convince, you cannot shout, you cannot scream. You have to respect the reality.
And that's the rapid fire question done. Thank you, Oleh. Oleh, to wrap this session up, what advice would you give to young engineers that are listening to this podcast who want to build a career in maybe in RF or semiconductor systems?
No, absolutely. And I already was asked this question on the panel for the young professionals that I attended in past. So I noticed, and I know that we all started our career at some point, and my kids are doing that right now. My children also in the workforce. So at young age, folks may have predetermined notion of what they do. I'd say be open to new things. Sometimes, life or destiny gives you certain opportunities. Don't fight it. Learn new things, and you may end up doing something exciting, interesting, that may become your life passion and career. I would also not try to chase certainty. Certainty does not exist. And I also, and this would relate to me when I was younger, do not worry, things work out. Do not get overstressed. As long as you do what you like, as long as you do good work, things tend to work out.
That's some good. I think that's a great message even for veterans or people that are in the industry as well, let alone young engineers. Thank you for sharing that, Oleh. Lastly, what's one message you hope listeners take away from maybe this podcast, your work, and your journey?
Yeah, so the one message that I want to give, and this is to me, to you, Salah, to our colleagues, the world of technology is amazing. I mean, the opportunities to learn, opportunities to invent something new, and opportunity to discover something totally unexpected are endless. So if you, in one way or another, related to technology, you're at a great place, and this is where we should stay.
There you are, Oleh. It's been an absolute pleasure having you on this show. Thank you for all these diamond gold nuggets that you shared. And definitely I would love to see your progress over the next few years and have you back again on the Have you reported back? Thank you. Thank you. Ladies and gentlemen, thank you for joining on the Semiconductor Leadership Podcast with Oleh at imec. If you want to connect with Oleh, you can connect with him directly here. The LinkedIn profile will pop up and you can connect and follow him directly. For more information on imec, you just search him on Google and you'll find all the details that you need. Other than that, as I say, if you enjoyed this podcast, subscribe and most importantly, share out there to people that you know. And remember, it takes a village to raise a chip and it takes subscribers to raise a podcast. So thank you for joining. See you at the next podcast. Take care. My name is Salah Nasri. See you next time. Bye for now.